Hello again. This is section 7.6. We're going to be talking about probability of events that involve not, like if we say not drawing a queen when you draw one card out of a deck. So events that involve not and or, and then we're also going to talk about odds in this section. So let's dive right in. So our objectives: to find the probability that an event will not occur. Not occur. Find the probability of one event or a second event. So there's our or. And then understand and use odds. So the odds of winning are 5 to 4 or something like that. We'll understand what that means. Okay, so we'll talk about the complement rules of probability. So complement rules. So the probability that an event will not occur is equal to 1 minus the probability that it will occur. So we think about it, the probability of E plus probability of not E. So E either happens or it doesn't happen. So that probability needs to be 1 because either it happens or it doesn't happen. Okay, so if we switch that around and we subtract a little bit, we get this. Okay, or we can subtract in the other order and get the probability of E equals 1 minus the probability of not E. And sometimes it's easier to calculate probability that way. Because it might be really easy to calculate the probability of E directly, but maybe not so easy to calculate the probability of not E. That was a lot of knots. Okay, using set notation right here. We're going to talk about using set notation. So the complement of E is called not E. So when we write E with the little prime notation, it looks like an apostrophe, that is not E. So that's an abbreviation. So that means the same thing as not E. So the E prime, that's not E. So the probability of not E is 1 minus the probability of E. The probability of E is 1 minus the probability of not E. So just a little different notation that we can use for probability. All right, example 1, the probability of an event not occurring. So if you are dealt one card from a standard 52 card deck, find the probability that you are not dealt a queen. So in this particular case, it would be much easier to calculate the probability that it is not. The probability of not a queen is going to be easier. Let me rewind. I'm going to calculate the probability that it's not a queen by doing 1 minus the probability that it's a queen. It's just easier to think through the process. Okay, so what's the probability that we draw a queen? Well, that's 4 cards, 4 queens out of the 52 card deck. It's just easier to count the number of queens than the not queens. So we'll have 1 minus 1/13. That will be 12 over 13 because that 1 is 13 over 13. So we get 12 out of 13 for our probability. Okay, 4 over 52 reduces to 1 over 13, and then I can replace that 1 with a 13 over 13 and then subtract. Or you can use a calculator, but it's nice to be able to do these calculations without them as well. So 12 over 13 is our probability. Okay, let's talk about probabilities with mutually exclusive events. So first of all, we need to understand what it means to be mutually exclusive. So here's our definition. If it is impossible for events A and B to occur simultaneously, which means at the same time, if it is impossible for events A and B to both occur or to occur simultaneously, the events are said to be mutually exclusive. That's like if I draw one card, it is impossible for that card to be both a king and a queen. That kind of thing. So or probabilities. We're going to talk about probabilities of or when the events are mutually exclusive. So if A and B are mutually exclusive events, then the probability of A or B equals the probability of A plus the probability of B. That would be something like, what's the probability that we draw a king or a queen? If we draw one card out of that standard 52 card deck, the probability of a king or a queen would be the probability of a king plus the probability of a queen, because you can't the card can't be both at the same time. Now, in set notation, we often use set notation. We're going to use the union symbol for the or. So when we're doing probability, the union set means, or that union symbol, I should say, that union symbol means or. Okay? So the probability of A or B, we will often write it with the union symbol. So we read it the probability of A or B. The union symbol means or. In the next section, we'll do the intersection symbol. But for this one, union means or. So example 3, the probability of either of two mutually exclusive events occurring. So this is our or. Probability of mutually exclusive events occurring. So example, if one card is drawn, selected at random from a deck of cards, one card is randomly selected from a deck of cards, what is the probability of selecting a king or a queen? So the probability of a king or a queen is going to be the probability of a king plus the probability of a queen. Those are mutually exclusive. So the probability of a king is going to be 4 out of 52 because there are 4 kings in that 52 card deck, plus the probability of a queen, which is the same, 4 queens out of the 52. Remember, when we add fractions, denominators have to be the same. I could make that 8 out of 52. Or if I wanted, I could reduce those both to 1/13 first and then add them up. So 1 plus 1 is 2. Remember, when the denominators are the same, I can just add the numerators, keep the denominator the same. So my probability is 2 out of 13. Okay? All right. Or probabilities with events that are not mutually exclusive. So we're talking about probability of an or, probability of A or B, if event A and event B are not mutually exclusive. Remember, the union is the or. So if A and B are not mutually exclusive, meaning they could happen at the same time, or they have something in common, then the probability that A or B will occur is determined by adding their individual probabilities and then subtracting the probability that they both occur simultaneously, or that they both happen. Okay, so or probabilities with events that are not mutually exclusive. Here's the formula we need to remember. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B happening. Oh, we do have the intersection. That's the intersection symbol right there. So that's the intersection. This one was the union. So the union symbol means or. The intersection symbol means and. Okay, and that's set notation. So the union, U is the union. It refers to the or, and the intersection, this is intersection, that's the and. Okay, intersection and union. All right. Okay, let's look at an example with that. So example 4, an or probability with events that are not mutually exclusive. So in a group of 25 baboons, or some animal preserve, 18 enjoy grooming their neighbors, 16 enjoy screeching wildly, while 10 enjoy doing both. And does that mean they're screeching and grooming their neighbor at the same time and their poor neighbor is covering his ears? Maybe. If one baboon is selected at random, find the probability that it enjoys grooming its neighbor or screeching wildly. Since 10 of the baboons enjoy both grooming their neighbors and screeching, these events are not mutually exclusive. In other words, we have some that are both. Okay, not like the card example where we had king or queen, but you couldn't be both, right? So the probability of grooming or screeching, we select that one baboon at random. What's the probability that that baboon enjoys grooming its neighbor or screeching well? So the probability of grooming or screeching is going to equal the probability of grooming plus the probability of screeching minus the probability of grooming and screeching. So probability of grooming is going to be 18 out of 25 because there are 18 out of the 25 baboons that enjoy grooming, plus 16 out of 25. That's the number or the probability that our baboon enjoys screeching, 16 out of 25. And then subtract the probability of both, but there are 10 that enjoy doing both, so that's 10 out of 25. Notice all those denominators are the same, so I can add them up by just adding, or combining the numerators, I should say. We've got some adding and subtracting. So that's going to be 18 plus 6, or 24 out of 25. Again, you can use your calculator on this. We get 24 out of 25. And if we needed a percentage, of course, we could just, a decimal or percent, we just grab our calculator and divide. Let's just double check that. So if I did 24 divided by 25, that's a really high, that's 0.96 or 96%, right? So be prepared to put it in decimal form on the assignment. You might even have some that ask you to write it as a percent. So it would be 96%, right? Probably 96%, really high. Okay, next example. Ooh, not an example. We're going to talk about odds. So odds. So we talk about the odds of, let's say we have a sporting event and my team has odds of winning. Let's see, the team that I like, the odds are 2 to 3 that they'll win. What does that mean? Well, I like to think of it kind of this way. If those two teams were going to play 5 times, my team would win 2 out of the 5. The other team would win 3 out of the 5. So there probably would be 2 out of 2 plus 3, or 2/5, which is 0.4, which would be 40%. So my team has a 40% chance of winning is what we're saying. Okay, let's go through the notes here, and it will explain it as well. If we know the probability of an event, we can determine the odds in favor or the odds against the event. So probability to odds, and then we'll do odds to probability. So the probability of event E occurring, P of E is the probability of event E occurring. We've been using that notation. Then the odds in favor of E are found by taking the probability that E will occur and dividing by the probability that E will not occur. And that will get to the odds in favor of E. So the probability of E divided by the probability of not E. The odds against E are found by taking the probability that E will not occur and dividing by the probability that E will occur. Oh, all right, that sounds really confusing. It's not when we put it in practice. Odds against E can also be found by reversing the ratio that represent the odds in favor. Okay, let's do an example and clear all this up. So example 7, from probability to odds. You roll a single 6-sided die. Find the odds in favor of rolling a 2. And then find the odds against rolling a 2. So let's do part E, and then we'll worry about part B. So let E represent the event of rolling a 2. Find the probability of E occurring and the probability of E not occurring. So the probability of E is going to be 1 over 6, because there's only one way of rolling a 2, but there are 6 possible outcomes, right? So number of outcomes that result in the 2 divided by the total number of outcomes, 1 out of 6. Probability of not E is then 5 out of 6, is the other 5 possibilities divided by 6. So to calculate the odds in favor of rolling a 2, we do the probability of E, which is 1 over 6, and we divide by the probability of not E, which is 5 over 6. Well, remember, to divide fractions, we take the one we're dividing by, flip it over, in other words, multiply by the reciprocal. So we change it from division to multiplication. We multiply by the reciprocal. That 6 is going to cancel, or we've got 6 over 30, which reduces to 1/5. Basically, I can just divide out that common factor of 6 from the numerator and denominator, and I get 1/5. In other words, the odds in favor of rolling a 2, or the odds of rolling a 2, we could say it that way as well. Odds in favor of rolling a 2, which could also be phrased as the odds of rolling a 2. Odds in favor of rolling a 2, or odds of rolling a 2, would be 1 to 5. We often write it as 1 to 5. So our odds are 1 to 5. Okay? The odds in favor of rolling a 2 are 1 to 5. Okay, let's do part B. The odds in favor of rolling a 2, we can find the odds against rolling a 2. That should be A. The odds against rolling a 2, we can just reverse it. Okay? I'm not sure why that's even there. I don't think it's supposed to be. We can find the odds against rolling a 2. That kind of confused me for a second. The odds are in favor of rolling a 2. I see what they're saying. The odds are in favor of rolling a 2. Wait, what? No, they're not. Let's just scratch that out. We can find the odds against rolling a 2 by reversing the ratio from above. So we can just do 5 to 1, right? I mean, you could go through the whole calculation, 5 over 6 divided by 1 over 6, but that's going to come out to 5 over 1. You can just reverse the ratio. If the odds in favor of rolling a 2 are 1 to 5, the odds against rolling a 2 are 5 to 1, right? In other words, the odds of not rolling a 2 are 5 to 1. Odds for, odds against. I think I'm still a little confused by that, so I'm just going to scratch it out. So the odds against rolling a 2, odds against rolling a 2, oh, we're struggling here. Odds against rolling a 2 are 5 to 1. All right. Odds for rolling a 2 are 1 to 5. Odds against rolling a 2 are 5 to 1. All right, let's go the other way. If we want to change odds to probability, if the odds, I got some serious typos in here. If the odds in favor of event E are A to B, then the probability of the event is given by this formula. So like we said earlier, basically if we had odds of 2 to, let's say, 3, that my team wins, that would mean the probability is 2/5 every 2 out of 5 times they played, basically, right? So this right here, if the odds of my team winning are 2 to 3, probability that they win is 2 out of 2 plus 3, or 2/5. Okay? All right, so this little formula is how we switch odds to probability. So let's do an example. Example 9, from odds to probability. The odds in favor of a particular candidate winning an election are 2 to 5. What is the probability that this candidate will win the election? So remember what we said. We just look at this and we go, okay, that would mean 2 out of 7 times my candidate will win, or a particular candidate, this candidate that we're talking about would win. The other 5 out of 7 times, yeah, okay. So it's really just that easy. You do 2 plus 5, which is 7. You do 2 out of 7. So because the odds in favor A to B means the probability of A over A plus B, the odds in favor of 2 to 5 means a probability of 2 over 2 plus 5, which equals 2 out of 7. So the probability that this candidate will win is 2 out of 7. If we want to grab our calculator and change that to a decimal, we do 2 divided by 7. We get 0.286 when we round it to 3 decimal places. I'm round it to 3 decimal places. So that's probably approximately 0.286, or 28.6% chance of winning. And that is the end of our video for 7-6.